Assalamu alaikum wa rahmatullahi wa barakatuhu. Welcome students. So in this chemistry part, we'll be learning about how the development of periodic table took place. So let's begin with the class. Why there is a need for classification. So now we know there are 118 elements till now. So those elements, if it is classified in a well organized way, it will be very easy to systematically study them. Okay, so if you're going to arrange them in a certain sort of order, that will give an idea about the chemical properties, how they are going to react with other elements. So now just look at this picture. It's colorful, right? What do you see? Yes, you can see the variety of chocolates, different colors, different texture, and as well as different size and shape. So if I want you to pick any one type of chocolate, will it be possible for you? Yes, it will be possible because they are just few in number. What if more number of hundreds and hundreds of chocolates are there? That time, how you are going to classify them? So is it very easy? Let's see. So given a chance, you can arrange them. Now, how did you get an idea that you're supposed to arrange this way? So we know there are different ways of sorting things. Either we can sort with the color, the shape, the texture, right? So by just doing this, we have organized things in a better way. Now, if you want any chocolate of any texture or color, easily you can pick and you can go for it, right? So this will increase ease of picking things. This is how the periodic table looks like. So you can see different elements are arranged. So elements which are made up of one type of atoms. Okay, we are going to classify those elements. Since they are present in large number, if we are going to organize them well in a systematic way, for that we should take some criteria. That means we should focus on some properties of elements so that maximum of elements can be grouped. So the earliest way how the scientists classified elements as metals and non-metals. But there was a problem. If you just classify elements based on metals and non-metals, there are instances where a third type of element arises wherein it will have both the properties of metals and non-metals. Then how do you group such elements? For that, there is a separate class what we call as metalloids. Now next, who's the first person who actually took the lead to classify elements? So what he did, he took the elements based on similar chemical properties, then tried to arrange them as per atomic masses. So when he did that, he found something interesting. Whenever he tried to arrange elements in a group of 3, he found that mean of these first and third element, the second element will have an atomic mass nearly equal to the mean of first 2 elements. So likewise, he could identify 3 triads. First is lithium, sodium and potassium. Second, chlorine, bromine and iodine. Third was calcium, strontium and barium. To take lithium, sodium and potassium, these triads will behave similar in properties. That means all these 3 elements are metallic in nature. They are highly reactive. Okay, and all these 3 elements will have 1 electron in the outermost shell. So let us move to the second. So here you can see chlorine, bromine and iodine. So in this, if you see, chlorine has atomic mass of 35.5. Iodine has 126.5. So when average of these 2 elements were taken, we could find that the atomic mass 81 was found. And this atomic mass was nearly equal to the atomic mass of bromine, which is the second element of this triad. He saw that these elements also, group of elements also had similar chemical properties. What is this in this case? They are all highly reactive non-metals. Out of all the known elements, he could arrange only few elements based on this atomic mass, and only 3 triads were formed. Therefore, this law failed. Thank you for watching. Hope you have understood.